Good evening, all. Welcome to the last day of our online program. Today we have Dr. Padmalochan Bera sir. So before sir will start his lecture, so let me introduce Bera sir. So Dr. Padmalochan Bera sir is working as assistant professor in the Department of Computer Science Engineering, School of Electric. It is under School of Electrical Science, Indian Institute of Technology, IIT Bhubaneswar. He received a PhD degree from IIT Kharagpur in the year of 2011, ME from West Bengal University of Technology, Kolkata in 2006, and B from Jadavpur University in the year of 2001. His research interested research areas are network and system security, advanced cryptography, software defined network, access control, security testing, and formal verification and optimization. He also having experience as a senior research scientist in Infosys lab and researcher at General Motors India Science Lab, and having also experience of postdoctoral research associate in Cyber DNA Research Center, University of North Carolina at United States of America. He's also executed so many projects while he was there at Infosys Lab Bangalore, and also currently executing so many projects from Bharat Electronics Limited, Mighty Government of India and others, DRDO and other agencies. He has also guided many PhD scholars as well as our BTech students in various research area. So with this introduction, I request Dr. Padmalochan Bera sir to start the lecture. Sir,
Thank you, Dr. Panda, for the introduction. Yeah, I'm privileged to participate in this online workshop. And, yeah, so before I start, let me share my screen. Please let me know if it is.
Yes, sir. Now it is visible, sir.
Okay. Okay. So, good evening, all participants. So today I am going to discuss two topics. First one is on application of AI in cyber security. Mainly, I will focus on designing intrusion detection systems using a reinforcement learning technique. And in the second part of my talk would be covering on advanced cryptography, especially attribute-based crypto systems for data security in cloud platforms. Okay, so we'll start with the first one, application of AI in cyber security. Okay, so if we see today's scenario, most of our services which we use daily, like uh, uh, switches. Okay, so various daily services which are heavily dependent on internet-based computing and communication. Okay, and also like in various uh, you know applications or in domains, we see uh, involvement of cyber physical systems such as power grid, where basically the electricity distribution to our home networks or our home equipments. Those are basically controlled by cyber physical system network called uh, power grid SCADA network. Okay, then in industrial controls, robotics, today healthcare, telemedicine, in most of the cases, we'll see that the physical devices are actually controlled by cyber components. Cyber components, when I say, that means it is computing devices, computers, servers, or maybe network devices as well. All are coming under cyber components. So you have physical devices, and those devices are functioning of those devices are controlled by cyber components. Okay, so in both cases, essentially, we exchange data through insecure communication channels. Okay, so in all these cases where we see the application of cyber physical systems or our daily use of application services, we exchange the data through insecure communication channels, and the and then also the network through which the data is transferred to remote devices. Those are very complex networks, which is ubiquitous in nature. Okay, very open, right? So therefore, it is obvious that cyber security violation uh, uh, could be potentially possible in those applications or in those environments. In general, if we see the security footprint or postures in uh, like cyber physical systems or in our daily use services, we divide it into three different way or three different domains. One is in computing platforms. In computing platforms, the security violations are mainly leading to disclosure or alternation of confidential data, such as active memory, program execution path, control network control rules, access control rules, through which, like firewalls, you have rules to allow or deny packets. So those rules can be modified. Disclosure and alternation of sensitive data in computing platform. Also involved with establishing unauthorized connections, like unauthorized sessions to the server, or unauthorized network connections to you know uh, web server or proxy servers, which essentially leads to degradation of quality. Okay, so this is in computing platform. In network infrastructure, if you see a recent report by NIST, it says that 60% of the cyber security violations today in various domains, these are actually coming from device level misconfiguration. Okay, so the softwares which you install in the devices, the firewalls you set in the operating system, so those rules, how do you protect the files, your your directories and all those stuffs. So the misconfigurations of those devices essentially leads to various forms of security violations. Okay, in fact, the devices need not to be configured independently. It has to be configured together. If a number of devices are connected in the network, then you cannot configure only one device as a isolated entity, and to for protecting the security violations. No, you have to look at that what are the dependencies with this device with other devices connected with the network. So until and unless you configure all the devices together with respect to a particular attack requirement, the security protections can be bypassed by the attacker. Okay, so therefore device level misconfiguration is the main sources here in network infrastructure. There are various types of rules: role-based access control, mandatory access control, even spatiotemporal access control, time, location-based access control. So various types of rules can be there, and password mechanisms, all those things has to be configured as a integrated network infrastructure. And the deployment is obviously distributed. It is not that, as I mentioned, it is not that rules are deployed in only one device. So rules are configured in many devices. Altogether, they should satisfy the security requirement. Changes in requirement, this is another important problem, that our requirements, like which packets should be allowed, which packets should be denied, okay, which websites are prone to phishing or various types of attack. So these requirements changes dynamically. Okay, so today my system requirement or security policy is something, and tomorrow my security policy may change. Okay, at the same time, today my network consists of, let's say, 100 nodes. Tomorrow my network may introduce more new nodes, or some of the existing nodes may leave as well. Okay, so when these changes happens, so you need to ensure that your devices are correctly configured. So the configurations which were done at the beginning, so those are remain intact, or the configurations which are supposed to be incorporated after the changes, that supposed to be indeed incorporated in the devices. Okay, so it's not an easy problem. So because of these device level misconfigurations, many attack paths to critical resources, computing platforms, so that may happen. Then most of the prominent attacks are in form of denial of service, hijacking of servers, network jamming, hidden tunnels. Hidden tunnels means that you reach out to a particular node through through, let's say, telnet service, and then from there you basically go to the internet. Though from your machine you might not be able to get a particular service or internet service, however you can go to some other device, intermediate device, through telnet, and from there basically you can go to internet. Okay, so many such hidden tunnels may be established. Then SQL injection, this is related to databases. Okay, so this sort of attacks are possible if devices are not correctly configured in the network. Okay, and therefore, and the we need to come up with solutions where basically lot of automations can be possible in the device level configurations. When you configure the device, so it should be automatically configured, okay, based on the requirement. Okay, so when we do manual intervention, like network administrator is basically configuring the routers or switches, there might be potential errors. Okay, or the dependency between two routers are not correctly assessed by the network administrator. So therefore, if we have some formal methodology that, okay, this is my requirement and this is my network topology, so based on this requirement, I am going to automatically derive the configurations for various devices, okay, in the network topology. So if that automation is possible, then obviously we can reduce this device level misconfiguration significantly. Okay, so this is another part. And then the third one is administration and planning. In most of the cases, the administration and planning are done based on web-enabled portal, web-based portal, and therefore uh, the major problem there is false information forwarding, denial of service, large number of requests coming to the server, and that basically consumes a lot of resources. Uh, the scripts which are running in the portal, web portal, so that might be also malicious, or there might be loopholes in those, vulnerability in those scripts, so that may launch various forms of attack as well. So you need to see that the language or the scripts which you are using, those are pretty secure, or even if it is not secure, then appropriate patch or appropriate versions are actually updated so that the regular attacks at least could be prevented. Not even if it is not the zero-day attack, but regular attacks can be at least prevented by versioning, appropriate updating of the servers through which the administration and planning is done. Okay, the websites which are basically used for administration and planning. So these are basically the security postures in different parts of our computing and communication devices, and therefore it is obvious that we need to come up with solutions to prevent the computing and communication platform. Okay, and if we look at the technically that what exactly the security violation means, so it is nothing but uh, violation of three important principles, that is confidentiality, integrity, and availability. So am I still audible? Please, anyone, if I am not audible, please interrupt me. Am I
Sir, you are,
audible?
yes, sir, you are audible, sir. Sir, if
Okay,
possible, you make it full screen, sir.
okay. Let me. Earlier it was full screen, or no?
No, no,
It was
no.
it was not full
It is
screen.
not in full screen, sir. View full screen mode, sir. View and you can check in view.
View
Uh,
full
in the file
screen for
menu, sir.
participant.
Yeah.
Is it fine now?
No, sir. Actually, it is not in full screen mode now, also, sir.
Okay.
Sir, you can press once. Try Control plus L, sir.
Because I tried with this view full screen mode for participants.
Yes,
Is
sir.
it fine now?
No, sir. Yes, sir. Now it is full screen, sir.
Okay,
Yeah.
that's
Yeah.
good.
Thank you, sir. Thank you,
All
sir.
right, all right. Thank you. So if we technically see what is security violation, it is we call it as technically intrusions, and it is nothing but compromising three important security principles, that is confidentiality, integrity, and availability. Confidentiality, we all know that the data which can be only accessed by authorized entity. Integrity, when data is in transit, it the if it is X is transmitted from the source to destination, then destination should receive X only, not X dashed. Okay, so data should not be modified in between. And availability obviously is that when service is requested by an entity, so it should be always available. So in the sense, the server is always ready for the corresponding service. Okay, so if any compromise to these three principles, then we call it as intrusions. Apart from that, various mechanism, few other concepts which are also very important in intrusions. Out of these, two important concepts are authentication. In authentication, essentially we validate the identity of the source of the message, source of the data. Okay, so authentication is also required in some of the platform or in some of the security uh, requirements. And apart from that, non-repudiation is another requirement, where basically when user basically generates the data and transmits place it into the channel, then later on it may not, it should not uh, 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 it should not it should basically ensure that it is indeed generated by the uh, 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 source. Okay, so it means that the data owner cannot falsify the ownership of the data in later stage, in any stage of the availability of the data in the system. Okay, so these two concepts are actually coming from CIA, but little bit some extra concepts are there, that therefore those two are actually handled in different way. Okay, different services. And intruders, if you see, there are in general external intruders, internal intruders. External intruders who are outside of your network or of the system, and internal intruders are basically systems inside the network. Okay, obviously external intruders, identifying external intruders maybe in today's scenario, maybe to some extent easier, knowing that we have good firewall mechanisms, we have good vulnerability database, updated vulnerability database. Okay, and good uh, filtering mechanism, control mechanism. So considering that external intruders may be easy to control or maybe easy to identify, however internal intruders who are basically part of your network, it is not so easy, because internal intruders are basically the stakeholder of your system itself. So therefore, whether how they are basically uh, misusing their privileges, so that identifying that is very important. Okay, so and considering the target in general, that target of the attack in general, intrusions can be classified into two types: network intrusions and system level intrusions. Network intrusions are basically trying to compromise the whole whole network of an organization, and system level intrusions are basically trying to consume the resources of a particular computing system or server. Okay, so these are and then to mitigate this, if we see, I'll skip this. These are very well known network intrusions: denial of service, distributed denial of service, man in the middle attack. These are some examples of intrusions in the network. Okay, some of them are basically leading to violation of availability, some of them leading to violation of integrity, some leading to violation of confidentiality. Okay, and few of these attacks actually also comes from you know uh, uh, weaknesses in the softwares which are being used in the systems, or vulnerability of the softwares which are actually used in the systems. It can be system level softwares or application level softwares, the softwares which are used in the router or in the servers. So from there also attacks can be uh, uh, possible, like UTR attack. So this tries to access the root privileges, okay, by different means like buffer overflow and other stuffs. Okay, so these are various forms of network intrusions. And system level intrusions, as I mentioned, it tries to target a particular host or server or a system by running malicious softwares to compromise the system functionality and corrupt the system, corrupt some components of the system, consume lot of resources, computing resource, I mean processing power or memory, and so on and so forth. Okay, and these system level attacks mostly classified under malware category. So viruses, ransomware, worms, adwares, and all are these system level intrusions, and these are all network level intrusions. Okay, so I'll skip these examples. So if we look at the solutions to these intrusions. So mostly there are three forms of solutions. Okay, one side is completely this is a completely different area of study because of its vastness, that is cryptography. So cryptography is one area where basically we develop encoding techniques. Okay, and that is uh, based on various security properties, one-wayness, then perfect secrecy theorem. So we try to develop a system, encoding system, through which data can be encoded in such a way that only authorized users they can actually who has the appropriate keys, they can only decrypt it and others not. Okay, but sometimes the cryptographic solutions are uh, uh, seems to be you know, computationally heavy. However, you know, in advanced crypto system there are various modern cryptographic techniques which basically targets to you know, develop efficient cryptographic solutions, right? Where basically computational efforts can be reduced significantly. At the same time, it would be much more usable when there are large number of users, like in cloud, various types of users they try to access the data from the cloud service providers, so or our cloud servers. So when heterogeneous users are there, how efficiently and in a usable way you can ensure access to those data in a secure manner. Okay, so advanced cryptographic techniques is one side, and the other solutions are like mainly firewalls and intrusion detection system. Intrusion prevention systems are basically extension of intrusion detection system with prevention capability. So firewall in general, it filters packets or traffic based on some well-established rules. Okay, and these rules are basically configured by your network administrator. Okay, so it can be based on IP addresses, port numbers, or protocols what are being used. So based on those, filtering rules can be written, and firewall filters those packet when it is coming to the network or going out of the network, or any software is being malicious software is being installed in in any systems which is part of the network. Okay, so such kind of traffics can be controlled by firewall. So therefore, if you know the rules or if you know the policies of the organization well ahead, then probably using firewalls, if you configure it correctly, then you can uh, protect various kind of external intrusion significantly. Okay, so external intrusions which are coming out of the network, so those intrusions could be prevented by configuring firewalls or designing firewalls in correct way. Okay, however, firewall has certain limitations because it only works based on known rules, right? It doesn't have much of intelligence in sense. So whatever rules you configure in the firewalls and whatever the parameters based on which you are configuring, like IP addresses, port number, then protocols. So only on those parameters it will work on. It doesn't work on content of the packet, payload. So inside the packet, if some script is there which is malicious, so that firewall will not able to detect. Okay, so firewall will allow that packet, and when this packet basically runs in your system, so basically the script runs, which is there in the packet payload, not in the packet header. So therefore, it compromise your system in that way, right? So firewall has certain limitations, and because of that, another very important prominent solution is intrusion detection system. So intrusion detection system actually targets to monitor the event occurring in the network or in the computer system for a period of time. So it observes, and based on these observations, it sees that is there anything which is abnormal, and based on that abnormality, it identifies that okay, this is basically an intrusion, and then essentially supposed to take preventive measure. So intrusion detection system objectively targets to identify network or system level intrusions by analyzing the behavior, okay, analyzing the behavior of the packets or the nodes who are communicating for a long period of time, and then it basically identifies that this is intrusion or so on. So, right now, intrusion detection also may work on based on signatures. So you can define a database. Okay, this is whatever attack signatures you keep in the database. Then based on that database, intrusion detection system can work on, or it can be based on behavioral analysis. Okay, so when intrusion detection system is based on behavioral analysis, that is much more interesting, and there are basically lot of possibilities of applying machine learning uh, uh, is there. Okay, so we'll talk about that. So therefore, if we look at the solutions to intrusions, in general, there are three classes. One is completely isolated class, that is cryptography, which is uh, 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 independent domain of study, and the other two are firewalls and intrusion detection. Okay, so already I mentioned firewall cannot protect against insider attacks. Firewall cannot protect completely new attacks cannot be, because it is doing based on the configured rule. So if something which is not there in the configuration, then those packets can be bypassed. Okay, and firewall takes decision based on only IP address, port numbers. Okay, but it doesn't look at the payload which is there inside the packet. So this may contain some scripts or viruses which may create problem. Okay, this is the limitation. And intrusion detection system, obviously it monitors the traffic and then detect the malicious activities in the network. Okay. General IDS requirements are it should run continuously in the system with less human intervention. Therefore, it should be automated mostly. So it should be a software which will be running in a server in your network or in your system, and that software will basically uh, uh, monitor the behavior of the incoming packets or the codes which are running, and based on that it detects that this is intrusion and it raises alarm basically. Okay, so it should run continuously and with minimal human intervention. It should be fault tolerant. If some functioning is not working, still it should work. The other components should work, or you know, there should be duplicacy, so that if one system fails, then the other systems can take over. Okay. Then resist subversioning. If the versioning changes for some components, still its functionality remains same. Okay, software versioning changes, still its functionality remains same. Minimal overhead on the system. It should be scalable because large number of users in the network may be there. So you need to. It should be scalable and allow dynamic configurations. That is very important, because your attack signatures may change over the time. Tomorrow a new attack comes in, so whether your monitoring system can identify those. Okay, so therefore dynamic reconfiguration is very important. Okay, if you see the architecture in general, it is a you can say that three entity system. First entity is agent. It gathers the data for analysis from the network or from the system. Then you have an analyzer. It analyzes the data. So the data which is obtained from the agent. So these are analyzed for a period of time to identify, and the notifier, this is the third entity which basically notifies the raise the alarm. So agent basically gathers the data, then director or analyzer, it analyzes the data and identifies the intrusion, and notifier reports the intrusion. Okay, so it's a basically 3 entity system, software system. This is IDS architecture in general. And if we see the different types of IDS, mainly 4 classes. In the first class, you have detection model based IDS. So here you have signature based and anomaly based. So signature based, it basically works based on existing database of attack signatures, and anomaly, it's based on behaviors. Okay. Monitoring environment, it can be host based or network based depending on the target system. Operation intrusion detection system can work offline. That means all the data you collect and give it to the analyzer. The analyzer process it, analyze it for a long time, and then it give a consolidated report that this is intrusion, this is not intrusion, and so on. And the more important and practical one is real time, which is online. So the data is coming online from different nodes in the network, and then your intrusion detection system or software detects the intrusions and reports it. Okay, so this is more practical. Architecture wise, it can be centralized. Your analyzer may run at a centralized location, centralized system, or it can be distributed, because if you make it centralized, then the computing overhead would be extensive. So rather you can distribute the analysis work to different components of the network. For example, if you have an institute network, you say that there are various LANs. In each LAN, there can be a agent which will be looking after the intrusion detection activities in that local area network. Okay. Similarly, in the other LAN, another component might be responsible for that. So there could be a a gateway router in one LAN. In every LAN, those routers there, basically you may install the IDS software, and that will take care of the respective LAN. So in that way, you can distribute the functionality of the intrusion detection system. Okay. Signature based, as I mentioned, so it works based on existing signatures. For example, one HTTP request packet comes, okay, from internet to your corporate LAN. Your firewall could not able to detect it, because uh, the uh, uh, the header is obviously fine. Based on the header information, firewall allows it. However, when inside the payload of the packet, there is a message called surprise, or some script is there, some string is there. So that is malicious. Okay. So therefore, intrusion detection system could actually evaluate the body of the packet or payload of the packet and identify if any such scripts or any such strings, malicious strings are there. Okay. Uh, so signature based only works on based on such kind of existing signatures. Like you have known signatures available, that okay, this signature is for this type of virus. So you have a database of signatures. Those database of signatures you put inside the intrusion detection system, implement in the IDS software, and then based on those signatures only, IDS will determine that this is intrusion, this is not intrusion. So it is completely based on signatures, not based on behavior. Okay. Similarly, you can see that another type. Okay. So the obviously the good thing is that signature based IDS will be very accurate, because you have defined signatures available. So its accuracy will be very high. There will be less false positive. Like some of the genuine packets will not be treated as false, not be treated as intrusion packets. So number of false positives will be less. It would be fast, because it would be simple, based on only just a string matching or database matching you are doing it. So it would be very easy to implement, easy to update as well, because your database you need to just add more signatures, then it is easy to update. However, the main problem of signature-based intrusion detection system is that zero-day attack. If any new signature comes in, so and then that is unknown, so such attacks cannot be identified. That is the main problem. And obviously, frequent update of signatures is not good for system performance. Okay. So therefore, the other one is anomaly-based IDS. Here we actually uh, uh, analyze the behavior. The IDS actually analyze the behavior of the packets or of the softwares, and it sees that if any event happens which is deviation of normal activity, we know that what is the functionality of a router, what is the functionality of a web server, what is the functionality of a particular system. We know that. So if anything uh, deviation from that such activity, such functionality, then we will consider it as a intrusion. So therefore, we do not have any particular signature here. We observe the behavior and activities, and if any event happens which is not usual one, unusual, so will be treated as intrusion. Okay. So for example, we know that in normal this LAN, TCP packet size is TCP packets incoming rate is, let's say, 100 bits per second. UDP packets rate is 112 bits per second. ICMP packets 43 bits per second. So this is given, let's say. Now you if you see that UDP packets are coming for a period of time which is like giving 425 bits per second, this rate, then obviously you will see that okay, this is something potentially can be malicious, because it may potentially lead to denial of service. Large number of packets are coming, UDP packets are coming, it might be potential candidate of denial of service, right? So therefore you are observing the behavior, and based on anything anomalous happens, then you identify that. Okay. So this is anomaly based, and obviously here two ways this can be implemented. One is threshold detection. You can define certain threshold. Threshold is not a fixed value, it can be a range of values or range of parameters. So if anything violates to those thresholds, then those will be considered as intrusions. And profile based, it basically characterize the past behavior of users and groups, then it detects the deviations from that. Okay. So two ways anomaly based intrusion detection system can be implemented. Mostly combination of these two are actually used in modern anomaly based intrusion detection system, both threshold as well as profiling. Okay. Obviously, anomaly based intrusion detection systems could prevent new attacks, novel attacks, zero-day attacks, and uh, problem could be if your uh, behavior, if your profiling and thresholding this is not good, then it might lead to high false positive. That there might be some packets which is genuine packets that would be treated as intrusive packets, because if your boundaries are not clearly not proper, thresholding is not proper, or if your behavioral analysis is not proper, then it may be, profiling is not proper, then it may lead to high false positive. And obviously complexity would be higher than IDS. However, because of the main advantage, that is it can detect many novel attacks, okay, many possibilities are there. Therefore today most of the IDS systems, practical IDS systems which are used in which are developed by various network vendors or security vendors, okay, you will see that they basically are anomaly based. Okay. Centralized distributed already I mentioned. And if we see if we want to look at how we evaluate the performance of an intrusion detection system, mainly two parameters, accuracy and false positive rate. So accuracy is basically ratio of true positive plus true negative, and sum of true positive, true negative, false positive, false negative. Okay. True positives are intrusions that are successfully detected by the IDS. False positive, normal or non-intrusive behavior that is wrongly classified as intrusive. True negative, normal or non-intrusive behavior that can be labeled as either normal or non-intrusive. And false negatives are intrusions that are missed by the IDS. Okay. So accuracy is this ratio, and false positive rate is false positive divided by total true negative plus false positive. Okay, for good intrusion detection system, our objective should be higher accuracy and lesser false positive. Okay, detection rate is not widely used. Accuracy and false positive rates, these are the two important parameters which are used for performance analysis. And these are the some data sets which are very widely used in today's research on intrusion detection system for analysis purpose, for analyzing your intrusion detection system, and also for training, for developing the profiling and the thresholding mechanisms. These data sets are basically used. One is UNSW NV15 dataset. You see here a lot of attack packets are there, and there are normal packets are also there. Some packets are which are attack packets, which can be, some of them can be used for training purpose, some of them can be used for testing purpose, and there are some normal packets as well. Mix of attack and normal packet. NSL KDD dataset is pretty old, but it was widely used for quite a long time. So and then this one is very recent one, and it is more Wi-Fi and cloud specific attacks. So the intrusion detection system which are used for cloud systems or for Wi-Fi networks. So for them, lot of attack signatures are actually available in this dataset, AWID CLSR dataset. Okay. So these data sets are basically used for training and analysis purpose. This is a description of NSL KDD dataset. I will not talk much about it. So there are, you can see that various types of attack packets are records are there in this dataset. Similarly, UNSW NV15, various types of attack records are there. AWID, this is another data set which is also used. Here you can see it's there. Okay, so far what we see that lot of potential attacks possible in our systems or in our network. So if we see the protection mechanism, firewall acts as a first line of defense, and then intrusion detection system should act as a second line of defense. Like if you see that firewall, you have a security here at the main gate of Rashtrapati Bhavan. So here he has certain rules, defined rules, by looking at the like your body, the checks or all the metallic check, testers or other things. They see that whether you are carrying pen drive or something. So those sort of stuffs are there here. So you look at the packet header and you filter, and then when you get inside, okay, then basically it is intrusion detection system's role to identify the malicious act. So first line of defense always should be firewall immediately after the gateway router, and the second line of defense could be the intrusion detection system, which could be installed in the switch or anything as a server connected to the switch, or just before it goes to the campus network. Okay. Right now, where machine learning comes into the picture, obviously you can see, because the anomaly based IDS looks at the behavioral analysis. So there actually machine learning may come into the picture for training the system, for improving the performance, that like more and more new attacks can be detected. If you train with good data sets and appropriate features are selected, then your intrusion detection system would be giving better performance. So therefore, you see that in rule-based methods, these are the problems. Regular updates, static. It is static because, however, attack signatures changes dynamically. Frequent human intervention for rule-based IDS. So thus, IDS has to be adaptive. Adaptive in the sense, today my topology is this. Today this type of packets I usually allow. Tomorrow different services might be running in my organization, so I may need to allow different types of packet as well. So your system should be adaptive. IDS should be adaptive to those packets. Dynamic, it has to be dynamic, as and when attack signature or network topology changes, it has to be updated, and obviously it has to be more automated. Okay, least human intervention. So there you can see that anomaly based intrusion detection system and machine learning actually had a breach here, and where we can apply ML in intrusion detection. Okay, machine learning, I'll skip this. What is the difference between traditional programming and machine learning? Here you can see that result and data is the input, and output is basically a program in machine learning, right? Anomaly detection, it basically identify never seen before attacks or zero-day attacks. That is the best thing of anomaly detection over signature based. So we should use anomaly detection, but we should use machine learning on integrate machine learning in that, because machine learning is techniques are good for learning patterns or identifying. Okay, machine learning techniques can train the system for learning patterns and identify similar kind of thing. Okay, so therefore these two can be integrated, and obviously very important, advanced actors means attackers. They can create small changes in the packet and they try to bypass your intrusion detection system, right? So therefore your training data sets using which you are training your intrusion detection system, or the features which are actually you are using, okay, for developing your machine IDS algorithms, those has to be perfect. Otherwise, even if small changes in the packet, they may not match with any of the existing signatures, so it will bypass your intrusion. Okay, so that has to be understood clearly. So therefore, uh, you know, we have to devise sound evaluation scheme. We need to select good features and right model for the intrusion detection system. Okay, and if we see, these are taxonomy of ML. I will skip this. Unsupervised, supervised, semi-supervised. Reinforcement learning is widely being used nowadays because it has the rewarding mechanism. Because it has the rewarding or feedback mechanism, so it dynamically actually improves the performance of the intrusion detection system. So therefore, reinforcement learning is being used widely. Uh, Deep queue network, double deep queue networks, these are basically examples of reinforcement learning, and others are supervised and unsupervised learnings which are well used. Okay. All right. So reinforcement learning, as I mentioned, that in general, agent takes action, it receives observation from the environment, and it calculates the rewards, and these rewards are informed to the agent, and then based on that, agent basically changes its state. Okay, so rewarding mechanism is there, and that makes learning faster and accurate as well. Okay, you can see here this learning, how the learning becomes faster. Okay, the boy could able to learn that this is a face of a cat. Okay, earlier it is learning actually, and so on. After training, is matured to take a decision, right? So you can see this is our one of our research, which is on context aware robust intrusion detection system. where we apply reinforcement learning. So this is for network intrusion detection, and it's published in Computer and Security Elsevier. So here you can see that this is the architecture. Okay, here you have one context, and this is another context. You can see this is LAN 1, this is LAN 2, and in LAN 1 various hosts are there. They are connected through router, and then this is another context. So here different types of packet. Here might be different types of packets are coming, and this is the server central IDS. Here my software IDS software is running basically. Okay, the idea is that agents basically collects the packets from network. All these agents, they collect packets, incoming packets from this host. Okay, and then they basically uh, uh, runs the agent logic algorithm. So where basically it selects some, it trains the uh, it selects appropriate feature, then uh, cleans the data. Okay, and which features is basically relevant for the central IDS, that it basically identifies, and then based on that it generates the state vector or action vector, and these action vectors are basically sent to the central IDS. All these agents are sending action vectors. So it runs these agents basically runs algorithms, agent algorithms, and these calculates the action vector and send it to the central IDS based on the incoming packet. And then central IDS calculates the reward, and these rewards are informed to the agents. And then agents further improve its uh, 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 state vectors. Okay, and then further it overall performance of the intrusion detection system. Okay, so this is basically the idea. You can see this is the agent logic which is running in these routers. It takes the network parameters and host parameters for a given time window, for a, let's say, 10 millisecond or 30 millisecond within this period. Okay, so it takes the packets and all the incoming packets within this period, all the network parameters, host parameters, which are basically taken from there. The features which are relevant for intrusion detection, those are extracted, and the data is cleaned, pre-processed, and then we do feature selection, and then this feature vector uh, classifications. Here we basically use various classification, various classifiers we use in a network, deep queue network, and finally the agent logic is agent agent result is generated, and this agent result is actually sent to the central IDS. Central IDS calculates the reward, and finally it updates the deep queue network. You can see that from state vector to agent result, this action vector. So here basically deep queue network works. Till this point, all we pre-process the packets, then classification happens, and then the feature vectors are generated. Then after that, this training is happening here in deep queue network. Reinforcement learning here happens here. Deep queue network is there, and here agent result is generated. This is basically sent to the central IDS. And central IDS basically based on sandboxing techniques, kind of it use to identify normalcy and attack packets, and based on that it calculates the award, and it sends this award to reward to agents. Okay, for fine tuning the deep queue network weights. Okay, so this is the detailing. You can see that this is agent logic, agent result calculation. So various classifiers are used, combination of classifiers. So this is feature vector and the classification vectors from different classifiers are basically concatenated to generate the state vector, which I mentioned here. The state vector, different classifiers result, and the feature vectors are embedded together here. Okay, to generate the state vector, and this is given to the deep queue network. And deep queue network, different nodes, the output basically taken and concatenated to get the decision vector, And this decision vector and this classification vector, they are job to find the action vector. This action vector is actually communicated to the CIDS. Okay, and this decision logic is basically based on thresholding here. Okay, this is done here, and this is agent part. Yeah, and this is the IDS part, central IDS part. So central IDS part, basically it gets this agent result and feature vectors, and it groups the agents according to the context, that which context it is being used, whether it is a banking network, or whether it is institute network, whether it is a DRDO network, what type of packets comes. So based on that context, so sandboxing are basically used here for identifying the contextual information, and based on this context, it gets the information of agent result and checks whether it is attack status is attack or it is normal. Okay, accordingly it calculates the reward vector, and these reward vectors are basically sent back to the agent for further improvement. Okay, so this is the idea. And if you see the results, NSL KDD, UNSW, NB15, AWID, all three types of data sets we have used for training and evaluation. And classifiers used are this array, random forest, ADB, GNB, KNN, QDA. All different types of classifiers are used, and accuracy and false positive rates are reported. You can see NSL KDD is pretty old data sets. That's why accuracy is not so high with these different classifiers. But with UNSW, NB15 and AWID, you can see that accuracy is higher, especially for RF and ADB. Okay, as well as QDA here for AWID, and false positive rate is also low here in AWID with QDA classifier. This is the data set here. Okay, so based on these results, what we have observed that for NSL KDD data set, high accuracy classifiers are RF, ADB, and KNN. RF, ADB, and KNN, these are high accuracy classifiers. If you have NSL KDD dataset, sometimes you do not have access to AWID, UNSW, NB15 datasets, right? Or you may not have that that much of server space for storing this dataset or performance. So you may use old datasets or which is uh, which introduce less overhead, but accuracy in that case, you need to identify that which classifiers are high accuracy classifiers, right? So NSL KDD under that RF, ADB, KNN are high accuracy, and low false positive rate classifiers are QDA and GNB. They are giving low false positive rate, so that is good thing. And for UNSW, NB15, RF and ADB, they are performing good in terms of accuracy, and in terms of false positive, QDA and RF works fine, works good. AWID, RF, ADB, QDA, KNN, and QDA and RF, they are low false positive. So for these, you can clearly see that QDA and RF performance is reasonably good in most of the cases. So therefore, what we did in the next experiment, we take combination of classifiers. These are individual classifiers. We have run this experiment. Now we have used combination of classifiers RF, ADB, GNB together, RF, ADB, QDB, QDA together, RF, QDA, KNN together. Like that, 5 different classes we have created, and then we have run the experiments with different thresholding. So there we observe that for C2 combination, okay, UNSW NB15 dataset, accuracy and false positive rate is good, okay, with 0.7 threshold, right? Similarly, with AWID dataset with C4 C4 group like RF, KNN, QDA, and ADB and QDA, right? So accuracy and false positive rate is good here, okay. Yeah, and this is basically based on different attack types, that which type of attacks are really identified with greater accuracy by different classifiers. So you can see that QDA mostly detects all of the type of attacks, okay, pretty well, okay, except some of the attack like this one, worm backdoor. So because the data sets were UNSW NV15 data set were not having training data related to backdoor and worm marks. Okay, so that's why this is the problem. So therefore, data set is another important limitation. So if you have good data sets available, then that would be useful for training your systems. Okay, so and these are like yeah, this is for NSLKDD data set. Here you can see that DOS attacks, probe, R2L, DOS and probe, these can be identified with good accuracy. UTR also, right? Uh, yeah, in UTR, this is fine. What I mean to say here is, let's say QDA. Yeah, this is NSLKDD data sets. So here R2L, right? So this attack, you know, the accuracy is little less. Okay, you can see all the cases accuracy is little less for R2L. This is because of lack of lack of records for of R2L attack types. Okay, in NSLKDD. Similarly, for AWID dataset also, you can see that AWID datasets, flooding, impersonation, injection, this type of attacks are very highly identified with high accuracy, because the dataset is well rich dataset with this type of attack. Okay, and yeah, so with this and then these are some of the comparison with state of art classifiers, and we have observed that our model actually works well with AWID dataset pretty good. Okay, and yeah, and yeah, we have also done experimentation with adversarial datasets. As I mentioned, that small changes in the packet may actually bypass your intrusion detection mechanism. So what we did, we have generated adversarial data, and using this adversarial data, we train our model as well. On top of the DQ network with different classifiers, we use generated adversarial data sets, and using those adversarial data sets also, we have trained our systems, so that even if small changes in the data set, that can be clearly identified by our system. Okay, so JSMA technique we have used for generating the adversarial data. Okay, and we have used denoising autoencoder here for uh, you know uh, uh, improvising the training using adversarial dataset. Okay, with this, yeah, I would like to stop here. It is very important to understand that today the scenario where we have lot of new attack types are being generated, system level intrusions, network level intrusions, and therefore we need to come up with adaptive system, adaptive context aware intrusion detection system, and their machine learning and advanced machine learning techniques actually play a great role. Okay, and in fact there are modern research started uh, very shortly, so that is related to federated learning. That is another uh, area where basically it says that uh, here we are sending the state vector. So this data set we are sending, instead of sending the data set, we can send the model to the IDS, the central IDS, because if you send the data sets, these state vectors, it may contain some of the privacy information related to the nodes, the like related to the packets or related to the router from where it is going. So some of the privacy informations might be also attached to these state vectors. So that may actually compromise the privacy also. So therefore, instead of sending data, can we send only model parameters? Model parameters can be sent, and then reward can be calculated based on these model parameters by running this model there in the IDS side, and then again further fine tuning happens in the agent side. So this is called federated learning. This is coming in a big way for intrusion detection system. Okay, so with this I will stop here. If you have any queries, can ask. If you not, then
Sir,
we can have 5 minutes break. Yes,
sir,
yes,
Namaskaram, sir. My name is Gautam Rampalli. I have a
yes.
few questions, sir. Sir, is this IDS and DDoS both are the same or similar? And number two is IDS subset of DDoS or vice versa? The third question is, whatever the data sets which are there for IDS, especially from, I'm referring to Canadian Institute of Cyber Security data set. Whatever IDS data sets are there, can I analyze DDoS through these data sets?
Right. So first question, IDS. IDS, firstly, IDS is basically the system which basically gives you the decision. Okay, IDS is the software which tells you it decides whether packet is, whether it is a denial of service attack or whether it is man in the middle attack or R2L attack, whatever it is. Okay, so therefore in general, if you say that IDS and DDoS relation, IDS is a superset. IDS can detect other than DDoS, it can detect other types of attack as well. It can detect DDoS as well as it can detect other types of attack. Okay, and IDS, intrusion detection system, it is the software which basically runs and takes a decision that okay, this is intrusion, this is not an intrusion. Okay, so it's basically detection system. And DOS or DDoS, these are attack types: distributed denial of service attack, denial of service attack. These are attack types. These are particular type of vulnerability. However, IDS is the system who does the decision making. Okay, and IDS is basically, if you want to find a capability of IDS, I would say IDS is a superset of denial of service, because other than denial of service, many other forms of attack can be also identified by IDS. And CWID datasets, it can identify few types of distributed denial of service attacks, mainly related to flooding, mainly related to thin flooding, okay, bandwidth flooding, not related to application level denial of service attacks, but flooding related denial of service attack can be identified by CWID. I mean, can be, and you can use CWID datasets for training your system or IDS system for identifying those form of denial of service attack. Is this clear?
Yes, sir, it is clear. And regarding this data set, sir?
Yeah, data set, that's what I said. The data sets which you said, it can identify, it can be used for identifying the denial of service attack. The CWID dataset is indeed used for identifying denial of service attack.
Okay, sir. Thank you. Thank you.
Okay.
Right, sir. Thank you. Thank you very much, sir.
Okay. Okay. So any more questions? If it is not, then we'll have 5 minutes break. Then we'll go
Yes,
to
sir,
the
we'll
next.
take break, sir. After that, we'll start.
Yeah. Okay.
Thank you,
Yes.
sir.
Thank you. Dr. Ponda?
Yes, sir.
So should we start now?
Yes, sir. Please, sir.
Okay, okay. Let me share. Could you see the slides?
Yes, sir. It is visible, sir.
And is it in full screen?
No, sir. It is not in full screen, sir.
Now is it full screen?
No, sir.
Not yet.
No, sir. No, sir.
What about
Yes,
now?
sir. Yes, sir. Now it is.
Okay, okay, okay. So let us resume. I'll start the second session with the topic data security for cloud with advanced crypto system. Okay, just a second. I all. Yeah, sorry for the interruption. Am I audible now?
Yes, sir. Yes, sir.
Okay. Yeah. So as we know that in cloud we usually store data owners or various stakeholders. They basically store large volume of data, and they usually provide access to the customers, their customers, as and when required. So in such setting, it is obviously very important, especially for uh, you know critical situations, safety critical situations. The authorized users can only access those data, and others are not, right? And this is very important uh, to ensure data security in cloud platforms or any other applications. And cryptography always is a potential solution to such data security problems. Okay, so in general, if you see, cryptography is nothing but it's a encoding technique that takes a plain text and use a predetermined key and encodes that plain text using that key to generate a ciphertext, and then it sends through the public channel or insecure channel to the receiver. And in the receiver, upon receiving this encoded message or ciphertext, It uses its decryption key to decrypt and get the message. Okay, this is when data is in transit, and when data is in rest, that means when it is stored in cloud server also, there also it is the same. Data owner encrypts it and store it in the server, and then customers when ready, so they basically access it by using its decryption key. But importantly, it should be one way, that is Oscar, who is an adversary, so it cannot determine the plain text without as it doesn't have the appropriate decryption key. Okay, so this is the basic idea in cryptography. So you see, this is the model. You have message, then you apply an encryption algorithm to generate the ciphertext Y using a key K. So you apply encryption algorithm using the key K, and this key can be also generated by some third party. Okay, trusted third party, let's say. It generates that key, and that key is shared with source and destination through a secure channel, right? The Alice and Bob both are having the key, and assuming that this key is not public. Okay, and message is encrypted using encryption algorithm using this key to generate Y, and then in the other side, the decryption algorithm is used using this same key to get the message back. Okay, and cryptanalysts, that means the adversaries, they basically try to do cryptanalysis on this Y. X is not available with it. It only has Y, and assuming that it has some computing resources, and by doing some analysis, it tries to get X kappa and K kappa, so that is very close to X and K. So even if it doesn't completely unfold unfold the message or unfold the key, so partially it can able to unfold, that is also good enough for the adversary to launch some form of attack, right? So cryptanalysis, what they do, they basically have this ciphertext and some computing resources, and based on that, it basically tries to identify X and key K. Okay, but that should not be possible with finite resources available. That is what the property of one ONS should be. Okay. So cryptology is mainly two competing areas: cryptography, that is how you generate the ciphertext from plain text, and cryptanalysis is breaking the cryptographic systems. Okay, and there are mainly two types of cryptography used. Symmetric key crypto systems, in classical cryptography, these are the two mainly branches. Symmetric key crypto systems, where you have a common key shared between two parties, and they use this common key for encryption and decryption. And in asymmetric key or public key, so basically two types of keys are available. One is public key, which is publicly available, everybody knows it, and another is private key, and private key is completely secure for every user. Okay, so using this basically encryption and decryption happens. If we define a crypto system, it's a 5 tuple plain text space P. This is set of all possible plain text. So let's say if I say alphabets, 26 characters, so all possible combinations of uh, alphabets would be the plain text space. Similarly, ciphertext space, set of all possible ciphertexts. Okay, if I say that only binary ciphertext, then of length n, then it would be 0, 1, exponent n bit binary numbers, right? So so all possible such binary strings would be in the ciphertext space. So you have a plain text space, you have a ciphertext space, then you have a key space. Key space is all possible keys. Okay, all possible keys that is there, and two algorithms, set of all possible encryption rules, and D is the set of all possible decryption rules. Okay, so these 5 tuples basically defines the crypto systems, or these are the entities in the crypto system, and the rule is for each key k from the key space. So there are all possible keys from this any random key if you pick. There is an encryption rule ek belonging to these encryption rules and a corresponding decryption rule dk belonging to decryption rules, such that if you apply encryption rule on uh, plaintext x belonging to plaintext space, and then again you apply decryption rule dk on that, you get back x. For every plaintext this should be satisfying, and therefore if k is known, then this is good. Okay, this should be quickly possible to compute ek of x and dk of ek of x. Okay, this is the property I am talking about. A practical crypto system should satisfy each encryption function ek and each decryption function dk should be efficiently computable, should efficiently able to compute the ciphertext and the plaintext, knowing the algorithms and the key. However, the adversary who doesn't know the key or the algorithm, either or maybe one of them, okay, or both of them. So upon seeing the ciphertext string y, it should not be able to determine the key k that was used or the plaintext string x. Just knowing string y, it should not able to determine key k or plaintext string x with in finite amount of time. Okay, or let's say even if with finite amount of computing resources within polynomial time, ideally we should say that it should not able to get key k or plaintext string x. Okay, so this should be a difficult job for the attacker. However, this is if key is available, then this should be easily computable. Okay, so this is called one-wayness. So this is the main property of one-way of crypto systems, practical crypto systems. But in as days passed from classical crypto systems to modern crypto systems, then basically the notion of the security, the one-wayness, this has been changed from I mean one-wayness to perfect secrecy. Then in perfect secrecy there were certain limitations, right? Because there in perfect secrecy it says that like one-time pad. Okay, there it is mentioned that the it's purely random. That means the mapping from plaintext to ciphertext using a particular key, it is purely random. That means knowing the ciphertext, going back to plaintext, it is absolutely difficult. Okay, this is what perfect secrecy says. But the problem is that if you have to make it purely random, then essentially the length of the key should be the same or greater than the length of the plaintext, which is not feasible, right? So you have 1 MB of size data that you want to encrypt, then for that you have to have 1 MB size key, which is unacceptable, right? So therefore notion of perfect secrecy again like modified. Then again in the modern cryptography we talk about one-wayness but with computations in mind. So we say that one-wayness needs to be achieved, but assuming that within finite computing resources, this should be at least satisfied. Okay, so these definitions are there. These notions of security of crypto systems has changed over time, and then as time moves ahead, various applications are basically heavy applications are developed, and those are outsourced to cloud. Okay, where a lot of high volume data are basically stored, and those are basically accessed by different entities. Then essentially the public key crypto systems or the symmetric key crypto systems are found to be challenging. Okay, found to be difficult to use in such systems, because in public key crypto systems, you know what we have, you have a plain text, and then for uh, a pair of parties, you have to have a public key private key pair, right? For example, Alice has uh, generated a ciphertext using the public key of Bob, and then the ciphertext is loaded into the cloud. Now Bob tries to access it, then it will decrypt using its private key. So you see that there is a public key private key pair, one pair of public key private key pair for one group of user. But then if the same message, same ciphertext is to be accessed by another party, let's say Bob and uh, uh, let's say uh, Chester, somebody else who basically tries to also uh, access this. Okay, and then he is authorized to access it also. So in that case, what you will do? So in that case, your plain text should be encrypted by two keys in a chain, so which requires extra computations, or you need to keep two different ciphertexts for two different parties encrypted by their public key for the same message. For the same plain text, you have to have two different ciphertexts keeping stored in the cloud, okay, so that two different parties can access it using their private keys. Okay, you see that the number of ciphertext that has to be stored in the cloud for a single plain text message to provide fine-grained accessibility to the different users, it's huge, right? So public key crypto systems is limited in that context, right? So therefore, you need to, instead of having private keys are mapped to individual ciphertext, okay, can we actually, instead of doing that, can we actually integrate a group of user, and for group of user, okay, we can have a ciphertext, and this group of user, if they share, if they satisfy their attributes, then they can only access it, otherwise not. You see, so therefore the ciphertexts are generated using uh, not using public key of a particular user, rather using a policy defined over attributes of different users who try to access this ciphertext. Okay, so this significantly reduces the overhead. At the same time, it is more practically applicable, because that is what we need in cloud, that fine-grained access control implementations for different stakeholders to access the data, right? And there basically slowly situations have moved, and advanced crypto systems like attribute-based crypto systems, those come into the picture. Second type is like uh, you have a ciphertext generated and stored in the cloud. Now one person, one user, it wants to only perform some computations on that ciphertext. It doesn't have to look at the plain text. It can only, it wants to perform the computations on the plain text and see the result, right? So for example, there are two ciphertext, ciphertext 1 and ciphertext 2, two files, and these are stored in the cloud, and we want to merge these files. So this merge operation is to be performed by one customer. So this customer wants to merge these files and see the merged result. Now for merging, what are you supposed to do? For merging, the file one supposed to be decrypted to plain text, corresponding plain text. file 2 also supposed to be decrypted to corresponding plain text, and then only these two files can be merged. So therefore, see, if you want to perform computations on ciphertext, you actually require decryptions of the large files, and that is a costly operation. Instead of that, can we do computations on the ciphertext itself without decrypting, and that is equivalent to performing merging operation on the plain text itself. So you are performing operations on the ciphertext domain, and that is indeed being performed in the plain text domain. Okay, so can we have such kind of mathematical constructions, crypto systems, which will basically ensure this type of stuff that reduces computations overhead significantly, right? So these are basically the idea for advanced crypto systems for practical applications, and that's why like homomorphic encryption, attribute-based encryptions, those are basically coming significantly into the practical place, replacing existing like standards like AES, RSA, and all those stuffs, slowly being replaced by these advanced crypto systems. Okay. So therefore, if you see the overall security challenges and solutions in cloud, as I mentioned before, data security challenges, it tries to satisfy confidentiality, integrity, availability, and also to some extent access control. And system security tries to prevent this form of attacks, various forms of intrusions, right? And data security solutions, mainly cryptographic solutions are used for data security, and system security, IDS, firewalls, these are used. In data security, public key encryption, symmetric key encryptions already we mentioned, identity based encryption, searchable encryption, this is another important thing. So this is very important, where basically you are having a large file, okay, and you are searching for some particular keywords there. So this large file is kept encrypted, and now you want to search for a particular keyword. So how shall you do in that encrypted domain? Searchable encryption, is it you can do it in encrypted domain, or you can, I mean, the entity which is performing the search, it is resource constant entity like mobile device. I'm doing it in my mobile, which has limited resources. So I can outsource this searching operations on in encrypted domain, or decrypting it and then search it to a outsource to a server which is having high resources, right? So this is searchable encryption, and then obviously attribute based encryption and homomorphic encryption. These are two important advanced crypto systems. Okay, in I'll be focusing on this one today. Okay, though I'll just touch upon homomorphic encryption this. Okay. So limitations of traditional crypto systems, as I mentioned, data security can be achieved using encryption techniques. Limitation is lacks of data scalability. If you have large volume of data, okay, then public key crypto systems, symmetric key crypto systems are not suitable there for so many volumes for efficiently implementing it, and also for fine-grained access. Deploy public key infrastructure and certificate management functions. So PKI and certificate management is important for public key or public key crypto systems, which is costly also. So it's a separate functionality you need to introduce here. It doesn't allow computations on ciphertext. This is the homomorphic encryptions I was talking about. All the traditional crypto system doesn't allow computations on the ciphertext. That means our construction was such that if you perform additions in the ciphertext domain, then it is not addition in the plaintext domain. If you perform multiplication in ciphertext domain, it is not multiplication in the plaintext domain, right? So such type of construction were not there. Though RSA is partially homomorphic, it is additive property, it satisfies, multiplicative doesn't. Okay, so lacks of expressiveness of data sharing. This is very important. That fine-grained access control, that different different people, they try to access. For example, faculties, students, they want to access resources stored in a database server, which are encrypted, let's say, and some components can be accessed by faculties, which some components can be only accessed by students. They cannot access the resources which are accessed by faculties and something, right? So such kind of access control, expressiveness, you cannot enable in traditional crypto system. Okay. So therefore, the public key crypto systems are basically being associated with the concept of attributes. So attribute-based encryption is again a public key crypto system. So where you have two types of keys, public key and private key, but their attributes are associated for generating the key. Okay. So you see here you have the authority where you can have various types of attributes, department CS, electrical engineering, type PhD student, alumni, male, female student, based on birth years, you can various attributes users can have. Okay. And so a master secret key, this is a key which is generated by the trusted authority for different users based on their attribute. So based on the attributes of user, master secret key, these are generated by the uh, trusted third party for different users, which will be used for a decryption operation. And then you have a public key. This public key is actually this is public, and this is available for all stakeholders in the system. And this public key and the message, plain text message, along with a policy defined over these attributes, are used to generate the ciphertext. So what you are doing, you have a public key, this is generated by some third party again, and this is shared to all the stakeholders, public. MSK is secret keys, okay, or private keys, these are shared to only the respective users. Encryption happens how? We have this public key, we have the plaintext message M, and a policy. This policy is a data structure, so it is basically a tree which defines that which attributes are, or which combination of attributes are eligible to access the plain text. Okay, so these three things are actually used to generate the ciphertext. So in other way, basically the key here is dependent on this policy tree. Here the encryption key is dependent on this policy tree basically. Okay, and that is done, and then ciphertext is generated. Then basically the data ciphertext is stored in the storage server, which is untrusted. So that means someone who doesn't have the secret key, it cannot actually access it. That property has to be enforced here, because this is untrusted. So therefore this master secret key is from there, the secret key component for a particular attribute is generated, and that is shared to the respective user. Then respective then similarly another secret key component for the other user is also shared to the respective user from the master secret key, and these are basically used to access the data. So if this SA satisfies the policy, then only this C can be encrypted, decrypted by SKSA. Okay, and if it is not satisfied, like SKSB doesn't satisfy this, then C cannot be decrypted by SKSB. So this is basically the idea of attribute-based crypto system in nutshell. But internal mathematics is there for every stage, encryption, decryption. Okay, and even if this secret share generation, all those things, there are procedures or algorithms associated to each such steps. Okay, and one of the important problem of this attribute-based crypto system is that collusion resistance. Okay, so if it says that if none of the users can decrypt a ciphertext individually, they still cannot even if they work together. Okay. So what does it mean? That if let's say SKSB and SKSA, these two together, okay. So suppose SKSA is eligible for accessing this data. SKSB, it is also eligible to access this data. It is not eligible to access this data, but if they combine their attributes, then still SKSB, this SB should not able to access the data. So that means two users, by sharing their attributes, they cannot collude the system. This is called collusion resistant. Okay, it may happen that two users independently they are not able to access the data, but when they share their attributes, they are basically your policy tree is in such a way that they able to access the data. Okay, or are they able to decrypt the ciphertext, right? So that should not be allowed. Your mathematical construction should not allow that if none of the users can decrypt this ciphertext individually, they still cannot, even if they work together or they share their attributes together, right? So like this here, SB does not satisfy P, so it cannot access it. ST does not satisfy P, so therefore this also cannot access it. But if they combine it together, then their union should satisfies P, so this should not happen indeed. SB union ST should not satisfy P as well, the policy as well. Okay, so this enforcing this is very important in attribute based crypto system. Okay, then moving to homomorphic crypto systems. In homomorphic crypto system, as I mentioned, it performs computations over ciphertext. It doesn't require decryption. Okay, so our mathematical construction should be in such a way that if we perform addition in plaintext domain, okay, then it is same as performing addition in the ciphertext domain. You see here, this is encrypted plaintext M1, this is ciphertext C1 actually, this is C2. So C1 plus C2 is same as encryption of M1 plus M2, the whole message addition. Okay. Similarly, multiplicative property, if these two holds, then we'll say that we can implement any computations in the ciphertext domain, because all of the computations can be actually reduced to additions, combination of additions and multiplication. Okay, so this is basically the idea, but the problem here is that after performing good number of computations on the ciphertext, it may have that the ciphertext gets introduced with some noise. Okay, so if the noise is very high, then essentially it will not remain as ciphertext itself. So then the result will be different. So therefore, there is an extra step required periodically, that is ciphertext refresh. After few iterations of performing operations, computations in the ciphertext domain, you need to refresh that means you need to roll back the ciphertext back. The current ciphertext should be restored to the previous one, right? So that ciphertext refresh step is necessary here in this step. Okay. So therefore, considering these two crypto systems, the main motivations to the data security researchers is that is there any solution that integrates all advanced access control requirements, such as detection of malicious users, dynamic removal of malicious users in a single platform? Similarly, how to reduce computations on performing benchmark operations on ciphertext while providing fine-grained access to the user? Okay, so these are the two important questions that has to be addressed while developing advanced crypto systems or more features in these advanced crypto systems such as HE and ABE. Okay, so this first problem says that okay, now suppose you have created a attribute based crypto system. created an attribute based crypto system knowing some set of attributes, E, PhD, CS, UNG, these attributes, and some set of users. Let's say 2 users are here. Based on that, you already created a policy and you have created a crypto system, attribute based crypto system. Now, tomorrow, a new user joins. So, will you start from the scratch, or with minimal changes in this policy tree, you can incorporate these changes? Or tomorrow, one existing user leaves the system. So, when an existing user leaves the system, you should ensure that this user is not able to access this data anymore. At the same time, the other users, they are still able to access the system access the data. Okay. So dynamic leaving and joining of users to the system, that has to be enforced, and then that is basically part of these advanced features, right? Which I said that dynamic removal of users or detection of malicious users. It may happen that some user who leaves but still accessing the data, or some users which basically shares its attributes with other users. So how do you detect it? Can you have a timestamp which basically attached to that user who tries to share the attribute with other users, and based on that timestamp you can trace that malicious users? So those sort of questionnaires to be incorporated in the advanced design. Okay. So based on that, we have worked on these proposals. I will be talking about this first one because of time limitations. So the first one is the design of efficient multi-authority CPABE with traceability, policy updation, and outsource description for data security in cloud. First is multi-authority. So multi-authority word means that there are multiple authorities who basically manage the attribute. For example, there are users who belong to a software company, who work in a software company, who also access resources from the university where from he is graduated. So therefore, his university admin is also attribute authority. His employer is also attribute authority. Employer has some attributes for him, and his university from where he graduated, there are some attributes which are managed by that authority as well. So there are multiple authorities who basically manage the attributes of user, and those attributes are basically used for providing fine-grained access control to the data, and thereby the policies which are used for encryption, okay, which are coming from attributes are coming from two different multiple authority attributes. Okay. So then traceability is that if somebody leaks the information, that means leaks the secret key or the attributes, then that has to be traced. Policy updations, data owner can change the policy dynamically. Okay. So today your policy is that based on some attributes, tomorrow some policy you need to change the policy. So that should be possible with minimal changes in the system. And decryptions can be outsourced when the users are resource constrained users like mobile users. When they want to perform decryptions, then their decryption operations can be outsourced to trusted cloud server, where basically decryption can be done and the data can be shared to the users who tries to access it. So these features are actually incorporated in the first design. So therefore, here you can see multi-authority means you have university, their attributes, company, their attributes are used, okay, to define policy. So CS, manager, engineer, and or combinations, you can see. So therefore, there can be a user who belongs to CS department of the corresponding university, and he is currently working as an engineer in the company. So based on these two attributes, which are managed by two different authorities, the accessibility can be defined. Is key that master secret key MSK would be generated for university also, master secret key would be generated for company also, then secret key components for this user for master secret key of university would be actually given, okay, KCS, and from this authority K engineering also given to this. Okay, so these two keys are actually available for decryption purpose. Okay, so the features of the system: decentralized, multi-authority. This is decentralized. It is not completely a distributed approach we have done here, and large attribute universe we have taken. The number of attributes is large. The mathematics behind is prime order groups. We have used prime order groups, which is very computationally efficient as well as secure. Collision resistance, this already we have discussed. Policy updations we mentioned. Outsourcing decryptions, yes, that is also we mentioned that limited resource devices they can outsource. Traceability with zero storage overhead. So we can trace the users with zero storage overhead, in the sense that we are not traceability. We can trace that who is sharing the leaking the attributes or leaking the key by keeping the informations in the server, all the components for each users in the server. But we do not want to store those. Rather, with less storage overhead, like time stamping mechanism, we can actually trace that which user actually leaks the information, right? So this is it is now this is the architecture, or you can say system model of our proposed system. It consists of mainly 7 entities: data owner, cloud storage, users, third party, attribute authorities, trusted party, and proxy servers. Okay, so firstly, these third party, firstly attribute authorities, they basically generate the public key, and these public keys are basically shared to data owners and trusted parties. Okay, and there is another third party which basically generates the global parameters for different stakeholders, like data owners who has the data, who wants to encrypt that data and using policy and upload it in the server. So third party generates global parameter for all the stakeholders: data owners, attribute authorities, trusted party, and users. This is for basically for authentication, right? And this is kind of authentication, you can say. Now, based on the attributes public key, attribute authorities public key, data owners use the encryption algorithm for encrypting the message. So it uses message and the policy tree and this public key I mentioned before. So using that, it generates the ciphertext and it stores it in the cloud storage. And whenever a user wants to decrypt it, access the data, first what it does, it it basically outsource this to the proxy server. Okay, so for outsourcing this decryption, so if it can able to do it here itself, then it is good, well and good, by the corresponding secret key. So it decrypts it with its secret key, because if it has enough computational power for decryption, then it gets the secret key, and using that secret key, it decrypts the data. If it policy satisfies, then it will able to decrypt it. But it doesn't have enough resources, then it outsources this decryption operation to proxy server, and then proxy server generates the decryption result and share it with it. Okay, and if malicious users who leaks the information, for that user shares the secret key to trusted party, and from that secret keys the trusted party generates the malicious user's GID, group identifiers. These identifiers are shared with attribute authorities. Then attribute authorities actually finds the malicious users in the corresponding domain, corresponding authorities. Okay, and it can take necessary actions, discarding that user or removing the users and all those stuff. Okay, so this is the overall architecture of our proposed system. So third party this is the whole process. Third party invokes the system setup procedure to generate the global parameter. So there is an algorithm called system setup algorithm which generates these global parameters. Okay, and these global parameters are distributed to data owners, users, and attribute authorities and trusted entities. As I mentioned before, these global parameters are distributed. Then attribute authorities provide their public keys to the data owners, users, and trusted entities. So attribute authorities, they send the public key to these three entities: data owner, trusted party, and user. Okay. Subsequently, data owner encrypt the message to generate ciphertext CT and upload it into the cloud. Okay. Data owner if data owner wish to change the access policy on existing ciphertext, then data owner generate a policy update key and send it to cloud service provider. So this one policy updation I have not discussed here. I will discuss in the next few slides. So if data owner can actually change the policy also, so in that case it generates a policy update key, and that policy update key is shared to the cloud service provider, so that the cloud service provider updates the earlier ciphertext policy which are integrated with the ciphertext with the new one. Okay, so this is done mathematically. Okay. Yeah, the ciphertext is updated with the new access policy at the CSP site, cloud service provider site. Then, and users generate their secret key SK from secret key components obtained from the attribute authority. So attribute authority sends the secret key components from MSK, and this from the secret key components they generate their own private key. You don't understand, don't think that this is the secret key which is used for decryption. Decryption key will be generated by user only based on the secret key from attribute authority. Okay, and then this decryption key is used for decryption purpose. If there is any suspicious activity such as leakage, the trustability which is authorized by data owners, users, and attribute authorities invokes the trace procedure. There is another procedure called trace procedure. Like policy updation, there is another procedure called trace procedure. So this trace procedure is invoked, and this trace procedure takes suspected secret keys SK, public keys PK, and attribute authorities and global parameter as input, and based on that it generates the GID, global identifier, a group identifier of the malicious user, and this is outputted and reported to the attribute authority. Okay, so therefore this process runs here in trusted party. Okay, this GID generation process runs here in trusted party based on the public key, global parameters, and secret key of that suspicious users. Okay, and this GID is shared with the attribute authorities and it can take actions. Okay, right. So these are the algorithms which are used: setup, key generation. The setup has two components: global setup, authority setup procedures. Key generation is generation of key. Encryption and decryption, encrypt and decrypt. Outsource decryption, this is get transform key. If outsource decryption is outsourced, then the key, the secret key is transformed, and that key is basically shared with the proxy server. So there is a transform key procedure which is shared, and that is used for decryption purpose in the proxy server. Policy updation already mentioned. There is a separate procedure for policy updation. Ciphertext update also, CT update procedure is also there, which is part of, you know, when you incorporate changes in policies, right? Policy updation. These two procedures are used in policy updation process. And traceability trace procedure, which is invoked by proxy server, right? Trusted party, right? So trusted party actually runs the trace procedure. So these are the algorithms which are used, and I will mainly I will not talk about all the details. I will mainly talk about the policy updation and traceability, because these are the two important one. When there is a change in policy, okay, then the new policy and old policy are given as input, and basically uh, uh, the components which are basically changes in the policy tree, those are basically identified, and those components are updated in the policy tree. Such nodes are added in the policy tree, and that's how the new policy is added in the old policy tree itself. Okay, so for that, essentially what happens, the data owner policy update key gen procedure returns. It takes GP, PK, AP, and ADAS, PDAS. That means this new attribute set and new policy. So these as input, and it outputs UKM. Okay. So this is a key, and this update key. This update key is sent to the cloud service provider, and cloud service provider runs CT update process, which takes CT, that ciphertext, earlier ciphertext as input, and UKM as input, and it generates the updated ciphertext CT. Okay, and this is comparison of policies, old policy and new policy comparison, and this is the whole process that is basically done. Okay. There are mathematics behind policy update keygen and CT update. I'll skip here those stuffs, but this is done, and it has been verified also that all these procedures working fine. Okay. Design of okay, so now outsourcing decryption. This is another function, as I mentioned. When limited resources you have, then you can outsource the decryption. For that, user apply gen transform key procedure algorithm. It takes input global parameter CT, ciphertext, and the secret key, and it outputs the time key component RK and CTM ciphertext. You know, CTM is another component which is basically related to some variant. I mean, you can say that some variant of the ciphertext. Okay, modified component of the ciphertext. So these components are basically used to the sent to the proxy server. Then proxy server use the CTK and TK to generate the you know, generate the CT dash output, that is very close to the plain text. Okay, so it doesn't completely generate the plain text. Complete plain text it doesn't generate. Then basically security might be questionable. So CT dash out is generated, and this CT dash out is sent to the user back. Then from that CT dash out it generates them, because this is the main heavily computation component. So therefore these components are basically sent to the proxy server. Okay, and at the same time security also maintained, because the proxy server is not generating the M, and proxy server is also not getting SK, it gets TK. Okay, user's key it is not getting, some modified component it is getting. Okay, so this is how basically outsourced decryption is happening. Traceability, it takes secret key SK from user, and basically this trace procedure is run in trusted party. It generates the group GID, and this is reported to the attribute authority. Okay, so these details of this outsourced decryption procedure functions are available here. I'll skip it. I'll talk about the performance comparison. So you can see that the major you know, the our model the size of private key and public key, which are very limited compared to the existing techniques, and that basically makes the computation efficient. Most of the algorithms, execution of the algorithms efficient, and we use bilinear pairing operations here, and that is more secured and efficient, right? And we do not store the information for traceability. So identity table size, many other approaches, they store informations for different purposes. For traceability, we do not store any information. Outsource decryption, it satisfies. Policy updation, it satisfies. Many other techniques, they do not satisfy these two, which are very essential. Okay. And this is computation complexity for different algorithms. Okay, in charm simulation platform, crypto framework, we have done this. We use Python libraries. Execution time for different components are given here with respect to number of attributes in the attribute authority, number of attributes in access policy, okay, and number of user attributes. All three cases, you can clearly see that the main component, okay, actually is key generation here, okay, and encryption, right? And here basically key generation as well, right? So thus and the key generation encryption, all these components are mainly heavily computing components. But even then, with large number of attributes in different attribute authorities or access policies or user attributes, you can see that time is within 0.2 seconds. Okay, so not beyond 0.2 seconds. So that is very effective for even mid-scale or large scale, semi-large scale applications where large good number of users, they try to implement fine-grained access control to access the encrypted data in the cloud server. And this is this is policy updation result. Policy updation takes very less time. We have two important extra mechanism, policy updation and traceability, that doesn't introduce much overhead. Okay, so that is what we wanted to show here, 0.12 second for different classes, and this is also in the range of milliseconds. Okay, trace time. Yeah, so with this we can say that the attribute-based encryption is one of the important future for practical applications, especially for large-scale scenarios where lot of dynamism is there. There are a lot of changes happens. User leaves, joins dynamically, and this is one of the advanced cryptographic mechanism which is will be deployed in such applications very soon. So essentially, it will replace some of the existing standards like AES, RSA, and all in such practical application. Okay, and proof of correctness, security, traceability, those are there. So I do not keep those formal proofs. We have the theorems, proofs, and all those things for correctness, security, and all. And adaptability also has been applicability has been justified with extensive experimentation with varying attributes and observing the timing and complexity. Okay, but here the in this proposal, basically malicious users we have not handled, but revocation of users, those are basically incorporated in the next proposal. So I will not go to that today because of time limitation, but user revocation is one of the important feature where you can dynamically revoke when some user leaves the system, then you can revoke the user from the system so that it is not able to access it anymore, even if it is trying to do so, right? So for that, various features like forward security, backward security, user evocation, these are actually attached to this CPAV crypto systems. Okay. With this, I would like to stop here. If there is any questions, please you can ask. And these works are actually, I mean, we have good number of publications from these works. You can get it in the from the internet if you have interest to do research on attribute-based crypto system. Okay. All right. So with this, I would like to stop here. If any questions, please ask.
Any participant having any question, you can ask.